Today is the third session of the AI Builder series. And also this is the first time that I'm going to demo the multi-agent. So the first two sessions are all single agent, right? Like just one agent invoking the tools here. And this session, we will focus on a multi-agent framework. We are going to build a deep research assistant. So for any topics of your interest, we can just throw the topic to it, and then it's going to do all kind of exploration, tool calling, and the agent's going to collaborating with each other and return of deep research report for the topic. So as I listed here, the author actually is by Manners AI. So the full tutorial notebook is 90% auto-generated by Manners AI, and I'm just playing the role of a supervisor for this notebook to make sure that it can run. And I have also done a little bit improvement over the storyline, and also there's some minor bugs to fix. And we are still going to use Strands agent like the previous two sessions. The backend is AWS Bedrock with the cloud API. The difficulty level, I would say like intermediate to advanced. So what you will learn, you are going to set up a Strand agent with AWS Bedrock. You're going to create multiple specialized agents with custom tools. And then you are going to call a swarm. So I think the swarm is also a very popular word in multi-agent right now. So everything is a swarm. So it's like a pool of agent. And to do the autonomous multi-agent collaboration. So you are going to build this deep research system with 5 agents, and then you will also see a very clear trajectory to see how each tool call and also how the agent hand off the work to each other. So that's the purpose of today. And then in terms of the system architecture, I mainly want to demonstrate how we can create specialized agents and how we can enable them to collaborate with each other, right? So I just say, okay, we define this 5 agent, but it's up to you. Say if you want to remove one agent or you want to add additional agent with additional tools, it's fully up to you, right? So this is just the starting point for you to know, okay, how can I set up a multi-agent framework? So for the initial setup, I have a planning agent to analyze topics and create research plans. And also it's going to propose the outline of the deep research report. And then the research agent is to gather information, like from using a free search engine, and then it's going to pass a URL from the search engine and trying to do the summarization there. The analysis agent is going to extract the insights from the analysis. Writing is just to write the report section by section. And then I also have a final critic agent is to review the full report, and then it's going to suggest any improvement if needed to the report. And before I dive deep into each of the agent and the tools, I also want, because this is a common question that got asked, like why Strands? Why not like LangChain on Graph or Crew AI or any other multi-agent framework? So I just want to list the key comparison here. And again, it's fully up to you which agentic framework you choose, right? So I chose Strands because it's AWS framework. And also it's a very simple learning curve. So it's very easy to understand what it's doing. So the ease of use is highest because it hides lots of things underneath. And also the orchestration is very autonomous. So you don't need to manually design the chain or graph there. You can just tell the agent what you want the workflow to be. And also it has a deep integration with AWS services. So if you are already using AWS services, this is a good starting point to using Strands that will save you lots of effort, say if you want to productionize it and integrate it with the AWS clouds. But if you are kind of embracing a multi-cloud strategy, right? Like if you want not just AWS, but also you want to have, a general multi-agent framework that can be deployed to any cloud of your choice. LangChain will be still a good starting point to learn, because it's a very mature multi-agent framework and also support like a multi-clouds, and also there's a big community to support this agentic framework. Yeah, so this kind of answers why I choose Strands, because for all my AI Builder series, I'm going to sit with AWS. And also it can help prepare to show how we can deploy agent later, and then it will be more streamlined over there. Then for the installation and setup, so you need to run, so you can just connect to I think CPU is also sufficient because I'm not loading any model locally. I'm mainly just invoking the LLM calls. So you can just connect to any instant like CPU or GPU sufficient, and then you can just install the required package. There's also a prerequisite for this to run. You need to have the AWS Bedrock configuration. So I'm just going to run this. So you need to have the AWS Bedrock configuration. If you don't have any AWS account, you got some free credit to begin with. So you can just register that account from here. And then you need to create the user who has the Amazon Bedrock full access. And then once you create that user, you can also create the access key. I demonstrate this process in the first session. So you can also watch my video tutorial later. Say if you don't, you can see the step-by-step of how to set the Bedrock up for this. So I think for the 100, and I think there's some additional 100 on top of the first 100 if you take some additional learning actions. There, I think it's already sufficient for the learning purpose. There. An alternative option that I also shared in the first session is you can also run a local Onama server and then run the models locally. So this is my Jupyter notebook for the first session of how you can pull up a Onama server and then load a small model there. So you can just run this fully locally without calling any Bedrock or cloud calls. So once you get your key, you need to kind of, so you need to create this like secret on the left-hand side, and you need to copy the access key for the AWS users from here, and then give the access to the notebook so that it can be loaded to the environment. So so you will see some dependency issue. It's fine. It won't affect any of the results. So if you see this, you already successfully installed all the packages required. And then you can run this so that we can load in the AWS keys and secrets. And then the third is to install the required libraries for today. So majority is Strands, right? Because it's using Strands agent. There's also, so DDGS is a free search engine. Maybe it's not the most powerful one, but I think for the demo purpose, it's already sufficient, and it returns a pretty decent list of search results from here. So I'm going to mainly use the DDGS search engine. Request is for the URL request, right, to pass the internet, etc. I'm also going to do some logging so that I can see the full agent interaction process. And other prerequisites is you need to have so this is the AWS package to invoke, to interact with the AWS services or Bedrock. So you can create a Bedrock client, and then you can invoke the LLM calls, right? So the default model is the Cloud4 model here. And then this is just to invoke the Bedrock call and then trying to pass out the JSON formats from the Bedrock returns. By the way, these codes are all written by AI. I'm just here like explaining, just to tell you like kind of explain what this function about, and so that as a supervisor, you kind of know whether you need to make any changes or you need the AI to iterate additional iterations there. Okay, so this is a basic setup. Yeah.
Quick question. Which AI did you use to write it?
Which I use the Manners AI, which recently acquired by Meta.
Okay, thank you.
Yeah, you see on the first like tutorial by Manners AI, if you click the link, it should directly goes to that app.
Gotcha.
Yeah. Okay, so that's the prerequisites and setup, right? On the libraries, on the Bedrock setup. And then you need to define the tools for each agent. So this is something new. I asked the agent to write. Is previously there's no file operation, so basically everything is in the memory, which will easily get lost, right? And then I say no, just give every agent a file operation tool. Right, so whenever they generate an output, they should just save all the output in the file system, so it will never get lost. So this is where this like a file write and tool for all the agents, so that they can save all the outputs to the file operations. And then I also have like a panel report, because the writing agent is going to write it section by section, right? So every time they finish one section, they're going to append that section to this report. There's also read the report. Of course, like in order for the file operation, you need to both like write and read over there. Okay, and then the planning agent is mainly to analyze the topic you give it to it. So there are mainly 3 tools over here. So the topic analyzer, this is just the LLM call, right? In order to write a deep research report for your topic, what is the key concepts, what is the complexity level, or what are the research area? Ask the LLM to propose a more detailed breakdown of your topic. And then the research planner is another LLM call over here. So actually lots of tools here are LLM call. It's more like a specialized LLM with a specialized prompts and specialized outputs here. And then it's going to create the subtopics and then develop the research questions for each of the topic. And then the outline generator is just going to create the outline for the report there, and to propose what is the outline of the report, to define the sections, right? So these are all the planner, the tool that planner has. And then when you define this, and if you run, okay, I want to analyze the topic, for example, AI impact for workforce, right? And then you will see what is the output from the LLM call. So it's invoking the LLM for this topic, and then the LLM response received. So there are some key concepts about the topic, like AI, workforce transformation, job replacement creation, etc., future of work. So these are the key concepts, right, that the LLM proposed to understand around this topic. And then there's the complexity level research areas proposed for this research report. Okay, so once the kind of the breakdown of the topic is done, and then it's going to pass it to the research agent. And then the research agent, the most important tool is, of course, the web search. Web search is kind of the knowledge for, kind of the default knowledge for the agents, right, to retrieve what is the recent information from the website. So we can use the DDGS, and I just ask it to return the top 5 results. And then it will also return the results, the corresponding URL, right? And then we can also provide the LLM a URL extractor tool. So it's going to pass that HTML website. Right now, I just pass the PDF because, yeah, I didn't develop anything to pass the PDF, but you can also add additional tool that if it returns a PDF, it can also load the PDF and extract the corresponding information from the PDF. That is additional tool that you can develop. Okay, so these are the research tool. Yeah, you may find it's a little bit long because the Manners write lots of except logics here, which is also important for the multi-agent system, because if you are able to capture all the exceptions, the agent is just going to continue, right? Like going to continue the loop. If it fails, it got the error back and it just continue. Because if you don't capture the exception, it will invoke an error and then it will stop the agent to do any additional work there. So one key lesson learned is, yes, you need to do lots of exception check, or ask the coding agent to do lots of exception capture, so that your multi-agent framework is robust and not stop at error, but able to capture the error and return the error to the LM for the next step. So this is also an example to do a web search, right? So using that free search engine, like top AI impact for workforce, and then it returns 5 results, like the AI ready workforce. This is the title, this is the corresponding HTML, and also some of the bodies for the HTML. And then you can also test the content extractor, right? So if I directly pass HTML for this extractor, can it extract all the tokens? So it extracts about 5,800 charts from this HTML web page, and then it's going to use the LM to summarize this web content over here. Right, so it will generate summary and what is the key kind of bullet points to that this URL HTML is about. Yeah. So that's the research, and then going next, you need to do some analysis, right? Like for example, to extract the key insights or identify the logical themes or categories. So this is again just the LLM call. So it's not like Python, like a web search or URL parsing function. This is just LLM reasoning, right? To extract the insights and then organize the insights into the themes, like theme 1, theme 2, so that we can make the report have a dedicated theme topic for each of the sections there. Okay, so once we done the analysis, then all the content is going to pass to the writing agent. Writing agent here is another LM call, right? Write a comprehensive, well-structured section for research report, and then you need to write it for each of the sections. So basically from your past previous planner there, so it will propose a list of sections to write, and then you can invoke the content writer to write each of the section with the data from the analysis, right? And then the requirements needs to be, you can also ask what is the requirements, and then you ask the format to be a markdown format so that you know what is the first title, secondary title, or third, right? And I don't need any syncing tokens or comments in the report. And then it's going to return as a string directly for the content. And then I may also want to add some citation manager here to help me organize the citations for the URLs that I refer to in the report. And then this is just some simple formatter you can add. This is just a very simple formatting as an example of just adding more kind of new lines, right? Like between before and behind each section. There, but you can add more like a Python function-based section formatter yourself over here. So this is a writing agent. It's mainly the LLMs and then the citation management. And then the last agent I put it here is the critic agent. So usually you need a quality check, right? To see whether the report quality is already good, whether there's any major issues. And if the quality is not good, I'm going to suggest the improvements and ask the writer, for example, the writing agent to write it all over, to do the refinement and rewrite it again. So there will be a quality checker to give some scores over here. And so I just asked it to generate some quality scores according to these dimensions. And then there will be some improvement suggesters, say if the score is above a threshold you set, say above 0.8, which is a threshold I set later, it's going to suggest what is the improvements here. And then this improvement is going to pass to the writing agent, right? So that the writing agent, for example, can refine the paragraph over here. Yeah, so that's the kind of the walkthrough of all the tools there. And now you can basically create all the agent with the tools, right? So here is again the backend is the Bedrock here. And then you have your planning agent. This is the system prompts for the planning agent. So you need to define the role and then make sure the output is also clear. The planning agent, you can also tell the agent how to use each of the tools, right? And then the research agent is define the system prompt, and then also you can tell, for example, hand it off to the analysis agent for synthesis. So basically, for all the multi-agent collaboration, you can just explicitly describe in the prompt what is the handoff, right? Say if it is all done, then you should hand it off to which agent next to pass the information over. And also you can tell explicitly like how to use the tool, right? To search, use the web search tool and then context extractor to extract the key content from the URL. And then I also want the agent say after you compile all the search, you should save all the results using this to save to a file. Same goes to the analysis agent with the list of tools over here. And then the writing agent, right? Again, the role, some of the important thing is like I want to just write a deep research report markdown file. And then the handoff is after finish writing, you can hand it off for the critic agent for review, right? So if the writing agent finish it, it will send to the critic agent, and then the critic agent is generate some quality score, right? So you can set the threshold here. So if the quality score is meets the larger than 0.8, you can just you can stop the handoff. That's it, right? You can jump out of the multi-agent loop. But if it's smaller than the threshold, hand it back to which agent, right? For example, if it's a writing issue, you should hand it back to the writing agent, and if it's like a key information missing, you should hand it to the research agent, etc., etc. This is just kind of what is the quality assessment format about, like, for example, list the strengths and list the areas of improvements over there. Yeah. So this is to define the agent. And next, we need to put them together. So put them together is actually very straightforward. You just create a swarm. And then you just put all the agent into the swarm. That's it. And then you can also tell what is the entry point. Like the planning agent is the entry point, right? Because it starts analyzing the topic. And then you will also set some timeout threshold and some maximum iteration just in case the agent forever talking to each other never jump out. Then you may want to set up some like a maximum iteration for it to stop. Right? And then you can create this. So I'm just going to run all. And then, yeah, so these are all the kind of the upper limit of how many iterations do you allow it to happen among the agents. Usually it should stop before the upper limit is reached. So that will be better, right? So you will see, like, if you run it, you should say like a swarm created successfully. And then once you create the swarm, you can just call the swarm. So this is the exact swarm, and just directly pass the topic here. And then you can see this. So actually this will take almost 10 minutes or more to finish. But you will see, like, for example, it's going to analyze the topic first, right? And then it's going to evoke the LLM. So basically, this is the first tool call. This is the second tool call, the research planner. And then the third tool call, the outline generator, right? So basically, this is all the tools you have created for the planner agent. And then you are going, and then you decide to save the output to this folder. So it's going to save the output. Yeah, I will show later. It doesn't show up right now. And then it will pass to the researcher agent, right? So you will see, oh, right now it's going to do the search, and to do the search and going to do the content extractor, like extract the content from this URL, and then evoking LM to summarize the content. And also sometimes it failed because the URL is forbidden. And then it's okay because we capture that exception, and you will just continue to go to the next step. Yeah, but it's very interesting to see like how this all happen autonomously. Like you didn't define like in what order the tool should be called or the agent should be called, right? So you just pass them all to the Swarm, and then it's up to the LM to decide whether to extract that URL. So some URL failed because it's forbidden for parsing, and some URL is okay to extract over there. Yeah. So you will see like a long tool sequence of like tool call, like 211, 212, like lots of like I also do some different topic search, right? And then it's going to extract the content from the web search results. This is going to run by for quite a while, but I can show you the outputs here. So this is the planning agent output, right? So you can see. Yeah, so this is the planning agent output. So it's going to, so basically for all the tool output, so topic analysis, key concepts, right? For the AI, for workforce transformation, there's the AI workforce transformation. So these are the key concepts. Research area identified, right? So this some automation, AI human collaboration, reskilling and upskilling, I think totally makes sense for the research area, and economic implications of AI adoption, etc., etc. And then there's also some research subtopics, and also it proposed some questions for the basically for the search engine to get more information over here. And there's also some methodologies of how we can do the reviews. And also there's some report outline, like you need to start with the executive summary. And then some method section, like 4 main finding sections with the research topics. So basically you are going to have 1 finding session per research topic. And then there will be some discussions and references in the end. Right? So basically in the agent output, you should be able to see all the output from each of the agent once the work is done, before they hand it off to the next agent over here. And then you should be able to see the kind of the full trajectories. As an example over here, actually it's going to take a while to run. And also it's going to kind of like retry multiple times. Okay, I think the research agent is done. It's going to just save all the outputs to this markdown file. Research complete. So this is kind of the main key findings. It does from the web search, and also the next step is going to pass it to the analysis agent to identify the themes, etc., before hand it up to the writing agent. Yeah, so you see that it's passing to the analysis agent, and then it's going to call the first tool, the insight extractor, and then the second tool, etc., right? Yeah, I think that's all the demo actually I want to share today.
How long did it take this to run, and how much did it cost? I'm just curious for a simple topic research.
It usually takes, at least for this topic, it takes about 10 to 15 minutes to finish.
Okay.
And actually, I limit the search returns, right? I limit it to just like 5 return from the search. If you increase the search return to 10 or more, it's going to take longer. So it's also there are many factors you can control to decide like how fast it can finish. So that's on the speed. The other is on the cost. So I think I have run this multiple times. And if I go to my Bedrock, my AWS portal, I see the cost upfront. And right now, from beginning to develop this, and I run it multiple times, right now I only got like around $10 in total so far. So it's not as that costly as I thought. But I think there's also lots of opportunity to optimize the cost. For example, like fully take advantage of the file system. Like you should just kind of the context management. So you can save all the tokens in the file system rather than loading them into the LM prompt or context every time. So it's going to save lots of token usage for the cost as well.
Awesome.
So yeah, I believe this notebook can further developed and can have more optimizations in terms of how we can, for example, make the writing agent more professional, because right now, as you can see the output, I can show later that actually the formatting is still not very good. There's a way to improve the formatting of the writing agent. There's also a way to improve the file system management so that you can basically just hand off, like do more of the token management while the file operations there. And also on the tools side, you can also think about other like specialized agent that can help improve the qualities of the report overall.
Cool, thank you.
Yeah, right now you see the writing is complete, is passing to the Critic agent to get a score. And then it's going to directly read from the local file, right? Like this is how many words so far, and then it's going to just evaluate it there. So Swarm is responsible for all your orchestration. So you just pass all the agent you develop. And of course, each of the agent you already pass the tools, right? Corresponding tools for each of the agent, and then you pass all the agent to the Swarm. And then we just tell the Swarm which is the entry point. The entry point, for example, is the planning agent. In the beginning, for whatever topic, is going to just use the planning agent to analyze it. And then the planning agent is going to hand off to the research, to the analysis, et cetera, et cetera. And the handoff logics right now is actually all described in the prompt for the agent, right? So if you see the prompt over here, so for example, this is the first agent, planning agent. And then you see after completing your work, you should save your research plan and you should hand it off to the research agent, etc. So this kind of describe the basic collaboration logics among the agent. And then you just leave it to the Swarm. You just leave it to the Swarm, and then the Swarm is just going to manage all that for you. You don't need to explicitly kind of build a step-by-step chain or pipeline for that. You just instruct that in the prompts, and then Swarm will figure out how to do the handoff among agent. Okay, it's complete. The interesting part is I think there will be a score. Yeah, so quality score 0.85, yay, and it's approved because I set the threshold to be 0.8. So it said, oh, okay, the quality score right now is like 0.85, it's larger than 0.8, and it's approved, and I should stop the agent loop, right? And then it's ended right now. And let me see yeah, so there's no back and forth. So basically, it just decides to stop after. Actually, from run to run, you will notice the different runs because the LM is not certain, right? So every run will get you a different report. And sometimes you will see there's some back and forth among the agent. Like Critic agent says, oh, there's like a 0.7, it's not sufficient. I will go back to the writing agent, and then you will become a 6 writing agent. And after the 6 is done, it's going to 7 Critic agent again to regenerate the quality score to see whether the loop needs to be ended there. Let me see what the deep research report looks like this time, because every time I got a different report. So I don't know what this one looks like. And let me see whether it can be loaded over here. For that, or you need to download it. You can just download it and actually I can just download it. Okay, impact of AI on workforce, future direction. So there's some executive summaries in the beginning. There's some workforce transformation. So there will be some new jobs, some jobs displacement, and 40% of core skills are going to evolve significantly. There's some inequalities and policies there. Some adaptation and investment returns, like about the 50% productivity gain. There's also some resolution period, like a 2-year for the transition. Yeah, some formatting issues over here. So this going to further develop for each of the theme, like the theme 1, workforce transformation and skills. What is the second one is economic inequalities, and theme 3 is going to be corporate adaptation, etc., etc. So it's going to write a very pretty decent deep report and future direction and recommendations, like integrated workforce technology planning approaches, multi-stakeholder collaboration, policy mechanism, continual learning ecosystem, and some recommendations for the stakeholders there. And also there are some references there. Yeah, so I think it's a pretty good, decent report with some formatting issues here and there, but it's I think it's a good content report to look at. Yeah, and I'm also going to share the report here. Let me see. I can share the report here in the chat. Okay, yeah. So next, so I think this is mainly just to show you, right? So how you use the Strands agent for this multi-agent framework, Swarm pattern, and actually Strands also support other graph patterns, which can be support more complicated patterns. I haven't looked at that yet. And then the key takeaways is this is autonomous collaboration, right? I didn't tell the Swarm how to orchestrate or how to kind of collaborate. Well, I kind of describe how to collaborate in the prompts for each agent there. But the actual execution is all happening autonomously. And then the OL agent will share the conversation history also automatically because I didn't specify that. And also I'm the supervisor role. I'm not even the developer for this. So the supervisor role is to kind of define the agent roles. Like I kind of just tell the managers, like, this is the main agent that I think will be helpful for this deep research generation, and just define like 2 or 3 tools for each of the agent, right? And also this is a very scalable architecture, meaning that it's very easy to add additional agents or add additional tools, additional MCP server on top of that. One key lessons I learned is we should use file system, because like yesterday evening, when I don't have the file system, I lost all the output. Like it runs, but I don't get any output. It's all in the memory, and it's a very hard time to figure out what is exactly written there. And also it's not efficient to pass the full context from agent to agent. And then I asked the coding agent to write this file, right? So that we know so that we can clearly see all the outputs for each of the agent. So I think this is a key lesson learned. And if I'm going to do any optimization, that I'm going to optimize mainly for the file operation management next. So the next step, so if you read the deep research that I just shared in the chat, I think we still need to enhance the instruction for the writing agent to make sure that the formatting and section organization is better. I'm also going to improve the interactions with the file system there. This will help you better manage the context efficiency and also optimize the cost. So as I said, maybe I have already run this like 3 or 5 times, and it just cost me around $10, not more than that. So, and also the report is quite decent. And also you can see the Critic outputs of this is the quality score, etc., etc. What is the strength of the report? What is the area for improvement? So I think it's a very good quality assessment as well. You can also try to add more specialized agents, right? So you can, once you set up the Bedrock, you can also try, what if I remove this agent? Can I still get that good quality report as previously one? Or what if I add a more specialized agent for your domain, like whether your domain is medical or AI or integrated with some domain database you already have, right? And then, so there are also other strengths pattern like the graph or workflow. Here is just a swarm. It's like autonomous orchestration, but there's also other formats that you can use for the multi-agent collaboration.